Hi, this is Mrs. Wiederhold, and welcome to my lesson video on solving radical equations. Now let's get started. In general, you solve equations by isolating the variable. You isolate the variable by undoing whatever has been done to it. For instance, given x plus 2 equals 5, you would solve by undoing the addition of 2. That is, the addition will be undone by applying the opposite, which is subtraction. So if you look right here, we have x plus 2 equals 5, and we are going to undo the addition of 2 by subtracting it. And when we subtract 2 from both sides, we have x equals 3. In the same manner, given something like negative 3x equals 12, you would solve by undoing the multiplication, by applying the opposite, which is division. And in our example here it is, negative 3x equals 12. The negative 3 is being multiplied to the x, so we can undo that by the opposite, by dividing by negative 3. And when we divide each term by negative 3, we have x equals negative 4. Now, when you have a variable inside a square root, you undo the root by doing the opposite, which is squaring it. For instance, given the square root of x equals 4, you would square both sides. And here's the example. We start out with the square root of x equals 4. Now, I can undo the square root by squaring it. So that's what I've done. I am squaring my square root of x. But if I'm going to do that to the left side, I also have to square the right side of the equation, and that's how I get x equals 16. The three previous examples represent inverse operations. If you need to undo addition, you subtract. If you need to undo multiplication, you divide. And if you need to undo a square root, you square it. Now with all three of these, you could do the opposite. If you need to undo subtraction, you add. If you need to undo division, you multiply. If you need to undo a square, you take the square root. Now a fourth example would be if you have the cube root and you want to undo that, then you would cube it. Now let's go over the special rules for solving radical equations. Number 1, radicals must be alone before you apply the inverse operation. Now what that means is before you raise both sides of an equation to a power, you must isolate the radical. The second rule is to be aware of extraneous solutions. Now extraneous solution may exist with radical equations. When we take the square root of a real number, we only want the principal square root, which cannot be negative. Therefore, you must check your solutions to determine if an extraneous solution exists. Now let's do some examples. Basically, there are 4 steps to solve a radical equation. Step number 1 is to isolate the radical, or the term with the rational exponent. Step number 2 is to apply the inverse operation to both sides of the equation. Step number 3 is to solve. And then step number 4 is to check your solution. Let's get started with example number 1. I have 2 times the square root of x plus 1 equals 14. Now step number 1 says that I am to isolate the radical. And I'm going to do that by dividing each side of this equation by 2. So I'm going to put step number 1 right there. And when I do that, I have the square root of x plus 1 on the left side of the equation, and on the right side of the equation I have 14 divided by 2, which is 7. So we've just done step number 1. Now step number 2 says to apply the inverse operation on both sides. So here I go. I've got the square root of x plus 1, and I am going to square it because that's how I undo the square root. So that means on the right side of this equation, I need to also square the 7. Now step number 3 says to solve. So if I have the square root of x plus 1 squared, I know that that is simply x plus 1. And on the right side of the equation, I have 7 squared, which is 49. So to solve for x, this is only one step. I'm going to subtract 1 from each side of the equation so that x equals 48. Now I'm ready to check my work, which would be step number 4. And all I do is take 48 and plug it in for x in the original equation. So I have 2 times the square root of 48 plus 1 equals 14. Now, I know that 48 plus 1 is 49. I know that the square root of 49 is 7. So basically, on the left side of the equation, I have 2 times 7. And on the right side, I have 14. And yes, that checks out. So we have solved for x. Now let's do example number 2. I have the square root of 2m minus 6 minus 16 equals 0. Well, step number 1 says that I need to isolate the radical. So I'm going to do that by adding 16 to both sides of the equation. And when I do that, I now have on the left side of the equation the square root of 2m minus 6, and then on the right side of the equation, it equals 16. Okay, so now step number 2 says that I need to apply the inverse operation to both sides. So I've got the square root of 2m minus 6 equals 16. So that means to undo the square root, I'm going to square it. And if I do it on the left side, I do it on the right side. Now I'm ready for step number 3, and that's to solve this equation. So I have the square root of 2m minus 6 squared, which is simply 2m minus 6. And on the right side of this equation, I have 16 squared, which is 256. So now I'm still 2 steps away from solving. First, I need to add 6 to both sides of the equation. And when I do that, I get 2m equals 262. Now I can divide each side by 2. And when I do that, I get m equals 131. Now I'm ready for step number 4, which is to check my work. So I've got the square root of 2 times 131 minus 6, and then minus 16, and that's supposed to equal 0. Well, let's look at my square root symbol. 2 times 131, so 2 times 131 is 262. And 262 minus 6 is 256. The square root of 256 is 16. And 16 minus 16 is 0. So this one checks out also. Okay, now let's go to example number 3. Here we have 6 plus the cube root of y minus 4 equals 9. Now step number 1 says to isolate the radical. So I'm going to do that by subtracting 6 from both sides of the equation. And when I do that, I now on the left side have the cube root of y minus 4 is equal to 3. Now step number 2 says that I need to undo that cube root. I need to apply the inverse operation to both sides, and in this case I have the cube root, so I'm going to undo that by cubing it. So that means I've done it to the left side, and I also have to do it to the right side. Now that I've done that, the cube root of y minus 4 cubed is simply y minus 4. And 3 to the third power is 27. Now I'm one step away from solving for y. I just need to add 4 to both sides of the equation, and y equals 31. Now let's check our answer. We start out with 6 plus the cube root of y minus 4. Well, instead of y, I'm going to put in 31 minus 4, and it should equal 9. Well, I would have 6 plus the cube root. Well, 31 minus 4 is 27. So I have 6 plus the cube root of 27 should equal 9. And 6 plus, well, what is the cube root of 27? It's 3. So on the left side of the equation, I have 6 plus 3. On the right side of the equation, I have 9. And yes, they equal each other. It checks out, so I have the right answer. Now let's do the fourth example. We have x plus 5 to the 1/3 power equals 3. The first thing we need to do is rewrite this as a radical. So that means I have the cube root of x plus 5, and that is equal to 3. Now step number 1 says to isolate the radical, and it's already isolated. There's nothing for us to move. So we can go on to step number 2, which is to apply the inverse operation to both sides. Well, the inverse of taking the cube root of something is to cube it. So we're going to cube the left side of the equation and the right side of the equation. Now, when we cube the left side of the equation, we get x plus 5. And when we cube the right side, 3 cubed, or 3 to the 3rd, we have 27. Now we are one step away for solving for x. We're going to subtract 5 from both sides, and we have x equals 22. Now we're ready to check our work. I'm going to plug this back into the original. So I've got 22 plus 5 to the 1/3 power is equal to 3. 22 plus 5 is 27, and 27 to the 1/3 power is equal to 3. Now I hope the notes you have taken and the examples we've done together have truly helped you into understanding how to solve radical equations. I look forward to working with you again. Bye-bye.